So today is all about examples. I'll do some first class function examples, but I want to start with a demo of some OOP stuff, I guess, just the example I chose. I want to show off how to use the debugger. So before we get into examples, these will all be just freestyle examples. Anybody have any questions? Or if there's anything specific you want to see during this lecture, let me know or hit me up in the Discord. In the lecture channel in the Discord. Anything? Yes.
Are the other parts of the project going to be posted?
Are going to be what?
Going to be posted?
Posted. Oh, yes. Shortly-ish. Over break, I'll definitely get those. Yeah, the parts of the doc are posted, but yeah, not in AutoLab because the graders aren't completely ready. But I'll be getting those out soon. I was hoping to get them done yesterday. I just didn't get them done. I was doing recovery opportunity processing yesterday. It takes a lot of time, unfortunately. But they will be up. Anything else? All right. So let's start with a demo that I've been putting off for way too long. I keep not finding time in lectures to do this. It takes a bit of time to go through this, but I want to show off the debugger, the best thing ever. So we have this TV example, and I want to show the memory diagram just to refresh our memory a little bit. We had this.
Why won't we use it?
Come on. You can load faster than that. So we had this TV example where we went through all of the stack frames, all the stack and heap memory, the whole memory diagram for this program with quite a bit going on. And I just realized today that I didn't push the new main method to the repo, so I did that today so you can pull from the repo, get the latest code. I had a lot more in this main method, and I trimmed it down for this example. So the trimmed down version is in the repo now for what it's worth. And we went through this line by line, went through everything that executes. We created a new TV, went into the TV constructor, set these state variables, went into the off constructor. The off constructor called the TV state constructor. And then whenever each method was called, we went down into the stack frames on stack frames on stack frames, and then they would return and go stack frame, return. And we could see the state of everything in memory and trace through this stuff. We can see this same information right in IntelliJ, and one of the common questions I always get is, can we get more examples about state diagrams? You know, we show a couple in lecture, but not all that many. So if you want more examples, you can go through the debugger in IntelliJ and see the same information. These memory diagrams, another misconception I've heard from a few students at least, the memory diagrams aren't made up. That's actually how the program is running. That's actually what's happening in the program. It's not just something that we sketch out on paper to make you do that. It's something that you sketch out on paper so you understand exactly what the computer's doing when you hit that green go button. Like, that's actually what's happening. So the debugger is going to let us do that. It's one of my favorite topics to talk about in office hours, but it's about time we get it in a lecture proper. So to use the debugger, instead of running this program using run, we just run it using debug. But before we do that, we have to set what's called a breakpoint. If you click right next to a line number, you're going to see this red circle, and that's what's called a breakpoint in your code. When you run the debugger, your program isn't just going to run and run through the entire execution of the program. It's going to run until, we're compiling for a while here, it's going to run until it hits a breakpoint. And once it hits a breakpoint, it's going to stop. And if my ID was on my same timing, it would have stopped exactly when I said stop, but we're not that lucky. So it's going to stop when it gets to the breakpoint, and it's going to show us the state of memory. Now, the format's going to be a little bit different than our memory diagrams, but right here, it's going to show us all of the variables in the current stack frame. And over here, it's going to show us all of the stack frames. So right now, we only have the stack frame for the main method. And in the main method, we have these two variables. We always have this. We won't put this on our memory diagrams, but even when we're inside an object, we're going to have the keyword this. So this is actually a reference to the object TV main. But we really don't care about that in anything we're going to do in this course or likely in your entire career. But that technically is. And then args, we don't put args in our memory diagrams either, but it technically is on the frame. And whenever you see this at symbol, at and then some number, that's the same as our OX and then some number in the memory diagrams. So if I see this at symbol and some number, I know that that's a value that's on the heap and that I only have a reference to that. I have a reference to an object of type TV main that's somewhere in the heap. And we can compare those numbers to see if two references refer to the same object. Now, once we run our debugger, we stopped at a breakpoint. Now the true power comes in. We can hit this magical blue arrow. This is going to advance the program by one statement. So if I click this button, it's going to step through the code just like we do in the memory diagrams. So if I hit this, I expect the next thing that's going to be ran to be executing, which I expect to be the TV constructor, which takes us right over to that TV constructor. And we can see the variables. So this is now a reference to the TV that's being created. And I can see its state variables, which it does jump ahead and declares these variables, but doesn't give them any values until we step through this code and assign those values. So we set volume, we set max volume, we're running all of the code. There's no constructor parameters, there's no inheritance here. So we're going right to all the code that's outside of the methods, and any variables that are declared out in this outside of all the methods are going to become state variables. So we create a state variable volume, state variable max volume. Those are members of this. I can do this dot volume, this dot max volume, and state, which is going to be set to the returned reference to a new off state, and I'm going to pass this reference 800 into the off constructor. So when we advance one more time, we're in the off constructor. This is a new object that happened to get the value 803. These numbers, like in the slides, I just make them up. They're pretty much made up in reality, too. They're just random numbers that, we don't really care what they are. We just care that that means there's something on the heap. And the TV is going to be our TV, a reference to our TV that's at 800. And we can see its state variables. Expanding this takes us over to the heap and shows us the values of those state variables. State is still null because we're waiting for the return value of this constructor. We hit advance one more time. It's going to take us to that superclass constructor, and we're going to get that reference to the same TV as our value TV here and call the TV state constructor. At this point, we can look over here and see all the frames on the stack. We started at the main method. That frame is still on the stack. The TV constructor with this equal to the TV. The off constructor with this equal to the off object, and the TV equal to a reference to our TV that's being constructed. And TV state, this being a reference to that off, and TV being a reference to that TV that's being constructed. So we're 3 constructors deep, and all those constructors are on the stack, which is the same thing we did over here. So we're at this point in the execution. Let's see the whole thing. We're at this point of the execution where these 3 frames are on the stack, a TV constructor, an off constructor, and a TV state constructor. All of them have a reference to the TV, and this, the TV, and TV. And 2 of them have a reference to the state that's being created. I guess I could go to the slide where this actually is. So we're right here in the execution. We have these 3 frames. We have these 3 frames on the stack. And I don't have max volume. I deleted that for the slides just to compact things a little bit. Same exact thing we can see in the debugger. We have TV constructor, off constructor, TV state. And the references, it doesn't matter what the numbers are, just that they're consistent. If they're referring to the same object, they should be the same. In the debugger, we have our TV, off, and TV state stack frames. And we can see the variables in each stack frame are going to be those references that we expect. A reference to the TV and the TV constructor. Off has a reference to the TV and a reference off, or a reference this to the off, which is right here. And in TV state, same idea. TV has a reference to the TV. This has the same reference to an off object as the off constructor. All of that information is actually how the program runs. The memory diagrams are not made up in any way. They're actually how things run. And you can confirm that in your debugger. And if you want more examples, just take any code and run the debugger. If you want to see a memory diagram example using the Hulk example, run that code, run the main method in the debugger, and trace through. What I would do if I really want to practice, draw your memory diagram, what you think is going to happen, and then click Advance on the debugger and confirm that that's actually what happens. So we'll advance this. The TV state constructor returns. That stack frame is no longer on the stack. The off constructor returns. That constructor is no longer on the stack. TV, the state, is going to get a reference to that state that was created, and then TV constructor will be off of the stack. And now we're back into the main method. And if we advance one more time, TV, the variable will be assigned. TV gets a reference to the TV that was created, and its state is going to be a reference to that state, that off state that was created. All that information right in the debugger. If you're using the debugger, if you're doing thorough testing and running the debugger, this is always my advice. I'll stick to this till I die. If you do both of those things, you probably won't need Piazza or office hours. You'll be able to find all of your own bugs. You'll be able to run the debugger and see exactly where things go wrong, where things don't work the way you expect them to. You might still need Piazza or office hours for really obscure questions if one of my test cases is giving you trouble or something. Maybe there's something that you'll still need that. But you'll be able to find all of your actual bugs. If your program is broken and you're not sure why it's not giving you what you expect, write your tests. If your tests fail, run the debugger and figure out why they fail. You'll figure out all of your questions. Very powerful tool. It will save you hours and hours of time. This is one of the things that the debugger is one of the things that I wish I learned a lot earlier. I learned it pretty late in my career when I was in grad school. And once I finally learned it, it's one of those, where has this been my whole life moments where it would have saved me so much time in my undergrad career. It'll save you a tremendous amount of time. If you get used to using this now, you're going to save a lot of time on the homeworks. So let's keep going through this. TV volume up. So TV.volume up. We're going to call the volume up method in the TV class, which is going to defer to the state. This, follow the reference, dot state, follow the reference, dot volume up. And then state has a reference to the TV. It's actually a circular reference, so we can keep expanding this till we get bored. But state is off, so I'm going to look in the off class for a volume up method. It doesn't exist, so we're going to look in the superclass. If you're wondering, okay, which method does get called, well, just run the debugger. The debugger goes into the TV state method. So we know that it inherited from TV state and it didn't override this method, so we're going to call this volume up, which does nothing. It's not abstract. It has a definition, and that definition is do nothing. Again, we can see the stack frames. Those 3 stack frames, main, volume up, volume up. main we don't put on our stack frames. It's the top level stack frame. Or we don't put on our memory diagrams. It's the top level. Where TV lives is in the main stack frame. And then volume up with two different references. I got to resize this a little bit if I'm going to jump back and forth between them. So we have volume up with a reference to the TV is this, and volume up with a reference to off is this. So we can verify all of that. We can see all that right in IntelliJ while we watch the code run. Method does nothing. Stack frame returns. Stack frame returns, and we're back to the main stack frame, and we're ready for the next method. The next thing is one of a real annoyance that I find with the debugger. I don't know why they programmed it like this, but I'm going to click this, and there are two method calls on the same line. Whenever you see this happen and it highlights two methods, the debugger is asking you, which method do you want to step into? Which method do you want to see the execution of? I really wish it would just go into the method that's going to be called first. This method has to be called before printline's called, so why not just take me into that one? But whenever you see this, click on the method that you're interested in, and it'll take you into that method call. So now we have current volume, defer to the state, current volume, return 0, return, and then we're back to this level. If we hit go again, it's going to give us the choice again. If you do what a lot of students do and what I used to do is you just say, just keep stepping, stop asking me questions. You might get something you don't want. So at this point, I click step into, and I ended up inside the print line method. If I hit step into again, I think, well, I'm just going to hit step into until I get back to something I'm interested in. It's going to go deeper into the print line method. We're going to get pretty deep into things. And at this point, we have quite a few frames on the stack. These frames that are highlighted a different color are internal to Scala. It's saying, hey, these are frames on the stack, but they're not part of your code. They're nothing we're interested in. They're nothing that's going to go on your memory diagrams or my memory diagrams in lecture. We're not interested in the internals of Scala. Whenever you find yourself in this situation in Scala or in the debugger, click this button, step out. This is going to resume the program until the current stack frame ends. So this is going to take us up one stack frame. I'm going to click this. We can see this stack frame go away. Click it again. That stack frame goes away. Click it again until you get back to your code. Now we're back into TV main. That's where we want to be. We want to be in the code that we care about. So whenever you find yourself deep into Scala internals, click that step out button until you get back to something you care about. Yeah.
If you step into a for loop, is it going to go through every iteration?
Oh, yeah. Yeah, it'll run one statement at a time, so it'll go through each line of each iteration of the for loop.
So then if you click step out, does it step out the for loop regardless of the iteration?
I want to say yes, but I'm not positive. I think it exits the current stack frame. If you want to get out of a for loop, what you would do is, actually, I'll show that. If you want to get out of a for loop, or you want to jump to some other point in the code, I'm going to set another breakpoint, and then click the resume button. Resume is going to resume execution until it hits another breakpoint. So if I'm not interested in these things and I don't want to care about what's going on there, resume, and then jump me to that breakpoint. So what I would do is set a breakpoint at the end, after the loop, and then hit resume, skip over the whole loop, and then start debugging again after that. So I don't know the exact answer to that question because that's the way I'll just skip my loop, is set another breakpoint. Now I actually want to be back where I was, so I'm going to set another breakpoint up here, get rid of my breakpoint here, and then restart the debugger. This will bring me right back to where I was. The references are going to be different. Those numbers are just made up. They're made up on the slides. They're made up in IntelliJ. They're made up in Scala. They're made up in the JVM. These numbers have no actual meaning. The only thing we care about is if the numbers match. We know we have two references that refer to the same object. That's the only thing we care about. Other than that, they're just nominal. So I don't have two things referring to the same thing right here. That's all we care about. So when I rerun the debugger, those numbers all changed. If I rerun it again, I'm going to get different numbers. Looks like they might be the same as the last time. We don't care what they are. We just care that those are references to objects on the heap. Yeah.
Can you step backwards between breakpoints?
So no stepping backwards. That's why I'm restarting. When I had to go backwards, there's no step back. There's no going backwards. And the last thing I want to talk about with the debugger, this button. These are this button, this one. There's a lot more power that this thing has, but these are the most useful ones. This one, this one, this one, this guy, and this guy. Those are the most helpful ones. What this step over is going to do is skip the next stack frame. So I'm about to enter a stack frame for tv.power, and say I'm not interested in that. I know that one's good. You know, say you're debugging the application objective on homework 1, where you're trying to figure out what the closest city is to a point, and you get to your call of greater circle distance, and say you've already debugged that, you confirm that that's working. You don't want to go into that one in your debugger because you're already done with that. You know it's right. I'm just going to skip it. Say I don't want to go into volume up either. I'm going to skip that one too. Okay, I am interested in current volume, so I'm going to step into current volume and see what's going on with that one. And at this point, the TV state has transitioned to on. It's a reference to on. It has a reference to the TV. And now I should expect to be in the on. Oh, on doesn't override current volume. It's a bad example. Let me go to volume up just to prove that point. Now I expect to be in the on class and call the on's volume up, which is going to increment the volume of the TV. And if I go, so that volume was just incremented on the TV from 5 to 6. If I go back to my main stack frame, go to my TV, since this is a reference to that same TV, I should see that change because that change occurred on the heap, not the stack. So I get to see that change across all my stack frames wherever I have a reference to that TV. That change was made on the heap. So anytime I have a reference to it, that change is visible as soon as it happened. So in here, volume is now 6. In the main, we just saw over here. Nope. This is the TV directly. Volume 6. We can verify all this. You can see everything that's happening in memory. Very powerful tool, very useful tool. If you get used to using this debugger, it will save you tons of time. I kind of regret waiting this long to really show a good one. I think a good example of the debugger, I think I briefly showed it in an earlier lecture, but not in enough detail to really be that helpful. So I want to show that. Any questions on this, on the debugger? I want to see you all using it. This is my favorite progression in office hours is show me your tests. You come to my office hours, my code don't work. Show me your tests. If your tests look solid, and your tests are failing, run the debugger. Show me what's happening in the debugger. Yeah.
When do you know what to put a breakpoint on? Because sometimes when I put a breakpoint on something, I go to the debugger thing and it just says no variables.
So sometimes you set a breakpoint on something, and what was that?
I run the debugger on the debugger itself, like you're on the debugger thing. It says no variables.
It says no variables. I think I'd need to look at an example of that. I've seen that before, but I'm trying to come up with when that happens. Maybe if we do this. Oops. Don't want to change any configuration. Variables are not available. It'll say that.
When you just had.
I know what you're saying, but I forget when that occurs. I forget when that happens. And there's this other tab here. I almost forgot to mention this. You can still see what's being printed to the screen. So once we hit print line current volume, after that method call, we can see what's printed to the screen still. So if you want to see any of your print statements, you still have that information available. Maybe that's when you run it in tests, I think that happens more. So when you run in your tests, oops. TV, hold on, I'll get there. You will get different, things will look different. You will get a lot more stack frames. You can see how involved the testing is. There's a lot of overhead that just to get to the point where your tests are being ran. When your tests start failing, or actually we can do it right here. If you accidentally get into the assert method, Why did it skip it? All right, hold on. I came this far. We're going to do this. And you'll get into this kind of stuff. If you're running in your test suite, you're running the debugger from your test suite, which is where you're most likely to be running it from, and you start seeing all this garbage and a whole bunch of stuff that doesn't make sense, you're going to see this when your test is failing. It's going to go through like 18 different method calls as soon as assert gets a false. If you see this, you know your test is failing. You can click this button to get out of here. Click it enough times, you'll get out of the thing. This outcome stuff, yeah, all this stuff. But eventually you'll realize, hey, my test is failing at this point, and you can shut things down. You know that specific test failed, and then rerun your debugger and step into a little slower and figure out exactly why it failed. That's how I never found time for this. It takes half an hour just to go through things. Any other questions on the debugger? Because I don't know when I'll find more time to talk about it. Probably not for a long time. Extremely useful. So if you come to office hours and you're not running the debugger, let me qualify that. If you have your tests, you run your tests and your tests fail your own code and you're not running the debugger, you know what I'm going to talk about in office hours. I'm going to see that as an opportunity to talk to you about the debugger. If your tests are passing your own code and you have a question about how Autolab is grading things, we'll have a different conversation. The debugger is not going to help us there. All right. So I guess I'm done with that. Nobody in chat. My phone wasn't connected to the internet this morning. It is this time. You're just not talking. It's fine. And let's get to some test cases. So let's go into song ratings. I'll show you kind of how to set this up. I'm going to steal this link. You can go to GitHub and get the link. I realized that students were just cutting and pasting that link. You're supposed to go here and get it, but it actually works by cutting that other one, so whatever. I'm not going to fight against that. Git, clone, or check out from version control on many of yours. Clone in this repo. Directory is not empty. 2. It's because I already cloned the project on this laptop. Clone in the repo. Mark source is root. I'm interested in test. Set up Scala SDK. 2.13.8 looks good. Should be able to run this test. Test passes because it does nothing. Learning terminally deprecated method in doubling. I'll ignore that. Some errors can be ignored. You have to know which ones to ignore. And my test passes because it doesn't test anything. So let's leak some test cases. Let's talk about test cases. This is pretty tricky how to call your methods that take first order functions. So let's discuss. I'm going to test the average method, test average with, we'll start with ints. So the average method, I give you the header in the repo. I'm going to cut and paste this just so I have a reference to what I'm testing. I usually like to do this, especially when I'm parsing text files. I'll paste the sample line wherever I'm testing and wherever I'm writing code, just so I have quick reference. I'm not jumping between things back and forth. So average is going to take a list of t, a function of t to double, and return a double, which will be the average of all the elements after that function has been applied to them. What does all of this mean? Well, let's start with some ints. Inputs list of int. And say I want to take the average of these. Let me actually match my param names. And I'm going to create a list of 1, 2, 3, 4 expected output equals 2.5. I want to make sure my return value is a double. If I'm taking the average of a list of ints and I have to apply the function and return a double, I want to make sure that I'm going to get a decimal portion here that's going to test if I'm actually doing things the right way. If I'm taking the average of the ints and getting 2 with the truncation, I want to make sure that's not happening. And I need a function, f, which is going to take, so t in this case is going to be int, and return a double. That's going to equal some function that takes some int and returns a double. Did that go by too fast? So here's my function. I realize there's a lot more to talk about than how fast I typed that. So I'm creating a function of int to double. I have a list of int. So t is going to be int for this test case. I'm creating a test case. Whenever you create a test case for a method that takes a type parameter, choose whatever you want for that type parameter, and then generate your test case based on that type parameter. So I chose t for int for this test case. I'm going to test the average of integers, a list of integers, and a function that takes an integer and returns a double. And my function is going to take that integer as a parameter and call toDouble on it to convert that integer to a double. Even if you leave the toDouble off on this one, technically Scala's gonna, I believe Scala figures it out and calls toDouble anyway. I like to be explicit. Let's be explicit and be sure that we're correct. If we're very explicit, we're not leaving it up to chance, we're not leaving it up to Scala to guess our intent. I'm going to be very explicit about that. And then I'm going to call val computed equals statistics lowercase statistics dot average. That should have been imported. No, it didn't. Oh, I don't have to import it because I gave the fully qualified name. Let me show it with an import. Statistics dot average. I'm going to import statistics. I don't know what it is on Windows, but I did Option Enter while hovering over, while having this selected. If anybody wants to know that shortcut, and that auto imports. Or if I think if you hover over it, it gives you the solutions here. The keyboard shortcut Option Enter. Import my statistics object and call average. I need a list of list of int in this case, and I named it exactly what the method takes. I need a function of t to double, so a function of int to double, my f that I created. And now I have what my method computed. I have the expected output. My only task left is to compare these things. I'm seeing way too much in office hours where you're saying assert math.absolute value subtraction less than 0.001, which obviously you're supposed to do. But there's a better way. Write yourself a helper method. Compare doubles. A double, B double. Turns a Boolean. And write a method that's going to compare doubles for you. And then here's where you would do math.abs, capital A minus B, less than epsilon, val epsilon. When we have a value, a bit of convention, when we have a value that's strictly a constant, it's never going to change, we typically do all capital letters, and my epsilon will be 001 is fine. So now I have a method that's going to do my comparisons, and then when I need to compare these things, assert compare doubles, computed, expected. And now I have my first test case for the average method. If Let me get this out of the way so we can see everything. This compare doubles, please write this as a helper method, and then just call the method whenever you need to compare two doubles. Because seeing the assert math.absolute value, subtraction, and then less than some small value, there's nothing inherently wrong with that. But the number of times I have somebody in office hours who spent hours trying to debug something only because they cut and paste wrong is very frustrating for all of you whenever you're going through that. I don't like seeing for hours and hours you're debugging something, and then I just go, you forgot your absolute value when you pasted it at that time. For some reason, you deleted your absolute value. Oh, son of a... And then they realize they wasted hours of their life. Just write this once, write it right once, and then you can even copy and paste it to all of your different test suites. And there's nothing to change. I think the error comes from cut and pasting the assert, and then having to change the variables that you're comparing, the variable names, and during that, accidentally hitting delete one extra time, and then you lose some information, you write it back wrong or something. Or maybe you're doing it from memory and you forget the absolute value. Absolute value is very important here. Without the absolute value, if B is bigger than A, it'll always return true. Because say I have A of 2 and B is 100, I'm going to get negative 98. Well, that's less than epsilon. So that's true. I've been seeing that mistake way too many times, so I want to squash that. I want to address it in lecture and squash it. Yeah.
Can we define epsilon somewhere?
Oh, yeah, sorry. It's the next line up. And we can replace this with whatever we want. So the flexibility in our average method that takes a type parameter and a function is that we can test things any way we want. So let's change our T to song ratings. Oh my goodness, I can't type. Change this to song rating. And song rating has two values, two integers, the rating and energy level. I have to apologize. I changed energy to energy level, but didn't update the handout code. Any of you who cloned the repo before yesterday, make sure you either pull, reclone, or change energy to energy level. That was causing some issues. Unfortunately, I overlooked one thing. That's all it takes to cause a mess. New song rating, and we'll give this some ratings. I don't know, a 5 rating and a 5 energy level. I'll just do 2 in the interest of time. And somebody who didn't like the song and thought it was a little less energetic. So we'll create our test data. And now our function is going to be a song rating instead of an int. So we can take that song rating and we get to decide what we want to take the average of. What do we want to take the average of? We have song ratings and we want to average these. Well, if I want the average rating, I'll take the rating of that song rating and I'll average this 5 and the 2, which should be 3.5. And I would expect that to be the answer. If I want to average, test average with rating of song ratings. If I want to do the same thing, but instead of rating, I want to test the energy level. Let's change this to energy level. I expect this to be 4.5, taking the average of the energy levels. So with one method that takes that computes averages, I can decide exactly how I want to compute. Maybe I want the average of the rating and energy level for some reason. I don't know why I'd want to do that. But we can take the average of anything. Same with the top k. We can get the top k of anything by any way. We get tremendous flexibility, just like our sorting methods, where we can sort anything based on any comparator. we're getting that same level of flexibility. This is the only average method you ever have to write in your entire program, at least Scala programming career. You write one of these for each language, and you could use that whenever you need the average of anything ever. That's the idea. Not necessarily that you'll do that, because average is simple enough. It's not that big of a deal. But if you have a really complex algorithm, like sorting, write that once. Write it generically, and then reuse it wherever you need it.
I don't remember shape.
The next two methods are, it's the same setup for testing as average, the top K and Bayesian average. For setting up the test, same idea. There's no new concepts I have to talk about. But the song cost function can get a little trickier. So let's talk about the song cost function. For that, we don't have any starter code, so we're going to have to go to the doc. And we're going to look at the method of this. So in music.music, write song cost function. So music dot import song, oh, right, obviously, because I don't have it written. Song cost function. Write a method that takes a map of strings to ints and returns a function. Oops. I might as well show you this part. So to write test for a method that doesn't exist, what's common practice, standard practice, and what I like to do is write a stubbed out version of the method, just like for the methods where you get the stubbed out version. Write that method that just returns nothing. So def song cost function is going to take a map of string to int as the user ratings. And it's going to return, I didn't pull it from the doc, but in the interest of time, returns a function. In the interest of time, I'll just write it out. That takes a song and returns a double, which will be the cost of that song. And I'm just going to return null. Null. I don't want to implement this yet. I want to write my tests first. But I want that to exist so I don't get errors here, and so I make sure I have my parameters set up right. So I'm going to create my user ratings, which is a map of string to double. Set that equal to a map that's going to do five. So the of YouTube ID to song ratings. So let's say the user really likes that song, doesn't really like this song, and you know what? Let's stop it right there. And we're going to give those user ratings to our cost function. Sorry, that's supposed to be int. To our cost function, this is going to return a function which takes a song and returns a double. Need to import song. When I'm doing that, I'm adding to my imports up here. So I have my stuff imported up here. I assume you all know how to do imports. I'm not going to, in the interest of time, I gotta keep this one moving. And then I'm going to take a song, val song of type song equals new song. And I'm going to take a song that's going to be rated. Do I give you the song class? Yeah. Need to make sure. Why isn't it giving me my hints? New song. Title. There's no time for a more interesting title. Me. And then the YouTube ID, we're going to make the YouTube ID equal to one of these. I'm going to grab this one. The YouTube ID, if you haven't ever looked at this, it's an 11-character string, which is going to identify that specific YouTube video. So we're going to take the YouTube ID, and then we need a list of song ratings for this song. This gets a little long. New song rating of, 5 and 3. New song rating of 4 and also 3. These people agree on what the energy level is. And then our computed cost is going to be the cost function. This is a function that takes a song, cost function of that song. The expected cost, well, we don't know yet. Assert, call our compare doubles, computed, expected. And what is the actual cost of this function, of this song? For this, we got to look through our things. So the cost is 1 over the Bayesian rating with 2 extra ratings of 3. We can do this quick. So 2 extra ratings of 3, so we have 5, 4, 3. 3 are the ratings that will be used for the Bayesian average. I should have done something that's easier to do the math of. Let me just change this to a 5 so we can do the math. So the Bayesian average rating of this song is going to be 4. And then 4 times the user rating, which is 5, so that's 20. The user rating for this particular song from the map is 5, so that's 20. And then 1 over 20 should be 0.05 if my math is right. And then we have our one test case for this. And then we'll want test cases for each of the ratings. If the user rated it, the song 5, if they rated it 4, 3, 2, 1, or if the user did not rate that song at all. There are test cases, incorrect solutions in Autolab for all 6 of those cases, so write at least one test case for each one of those. We'll get you there. We are at 3:50. I'm going right up until break. Sorry about that. I didn't want to go that light, but I don't want to leave you with a partial test case either. Once you're done with the lecture question, have an excellent break, and I'll see you in a week.